Here we are, 4.5 billion years into the lifetime of our Sun, with an array of planets and smaller objects orbiting around it. How did all the planets form, and why did they end up in the orbits that they did? The formation of the solar system is a challenging puzzle for modern astronomy and a terrific tale of extreme forces operating over immense timescales. Today we will discuss with you how our solar system formed. Welcome back to Signatures Live, and you're watching Signatures Science. In the beginning, there was nothing, but it wasn't quite nothing. All stars form from the collapse of nebulae, which are loose clouds of gas and dust. And our Sun and solar system are no different. Astronomers call it the pre-solar nebulae, and of course, it isn't around today. But we have seen enough solar systems forming throughout the galaxy to get the general picture. But a nebula on its own won't collapse into a solar system without something to set it in motion. In our case, we can thank a nearby supernova explosion, whose shockwave ripped through the pre-solar nebulae, causing it to begin its contraction. We can tell that such a supernova went off nearby because some supernovae release great quantities of certain radioactive elements that aren't normally found inside nebulae, but which we can see in our solar system today. Once underway, the transition from nebula to solar system was irreversible. Over the course of millions of years, the nebula contracted and cooled, eventually reaching the point where a proto-sun was surrounded by a thin, rapidly rotating disk of gas and dust. 4.5 billion years ago, our Sun wasn't quite that shining star that it is today. It was compact and very, very hot, but it hadn't reached the critical densities and temperatures needed to sustain nuclear fusion in its core. But while it was still in this embryonic stage, the planets began their slow waltzing formation. Close to the young Sun, the heat and light were too intense for anything other than rocky material to remain. The ices evaporated and the loose gas like hydrogen and helium simply blew away. Those remaining rocky bits slowly coalesced, sticking together to form ever larger clumps. Eventually, with enough time, those bits formed planetesimals, small almost planets. There were a lot of them, and it was quite a violent time for our solar system as these planetesimals collided, shattered, and reformed countless times. Our own Earth was struck by something nearly the size of Mars, and the debris from that impact eventually became our moon. Out past what would eventually become the asteroid belt, however, planet formation took a different approach. Out there, it was cold enough for ices to survive, allowing planetary cores to grow to immense proportions in a short amount of time. Those large cores were then able to hoover up any surrounding material like hydrogen and helium gas, enveloping those worlds in thick, swaddling atmospheres. That's how the giant planets were born. Once the planets matured, however, all was not calm in the solar system. The inner rocky worlds had stabilized and the Sun had ignited nuclear fusion. But the outer giant planets were surrounded by swarms of hangars of the leftover bits of debris from the chaotic planet-building process. Astronomers suspect that the 4 giant planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, initially formed much closer together than they are today, and subtle interaction with the remaining debris surrounding them caused them to shift their orbits. It took hundreds of millions of years to resculpt our solar system, and we are not exactly sure how it all went down. In one scenario, Jupiter and Saturn migrate inward toward the Sun, which caused Uranus and Neptune to drift outward. In another scenario, the worlds of our outer solar system play a game of gravitational hot potato with a bonus 5th giant planet that eventually got ejected altogether. In yet another, Jupiter wanders nearly to the orbit of Mars before jumping back out, disrupting the otherwise placid orbits of the remaining outer worlds. No matter what, this last reshuffling caused havoc. Astronomers think that the migrating outer planets gave rise to an epoch called the Late Heavy Bombardment, a period of intense comet and asteroid impacts in the inner solar system about 4 billion years ago. The shifting of the giant worlds disturbed all the remaining material in the solar system. either sending them to safety in the frozen outskirts or barreling inward to cause trouble for the rocky planets. Despite the violence, it wasn't all bad. The procession of comets raining in toward the inner solar system delivered an abundance of water to the rocky worlds, potentially making life, including us, ultimately possible once the solar system settled down.